Good morning, everyone. I am Dr.K.Dhanalakshmi, lecturer, PG and Research Department of Physics, Sithalakshmi Ramaswamy College, Tiruchirappalli. We have learned about elasticity. Elasticity is the branch of science that deals with the elastic property of the material. On the basis of elastic property, the materials are classified into two types. One is elastic material, other one is plastic material. Elastic material, the materials that regain their original length or shape or size after the removal of the deformation force. Example, steel, rubber, quartz. Plastic material, the materials which are not able to regain their original length or shape or size after the removal of the deformation force. Example, putty, mud, clay, wax, lead, and chewing gum. Stress. Stress is defined as the restoring force acting per unit area of cross section. That is stress equal to F by A Newton per meter square. There are three different types of stress: longitudinal stress, bulk stress, and shear stress. If the restoring force is acting perpendicular to the cross section and the length of the wire is called longitudinal stress. If the body is subjected to equal forces normally on all the faces, is called bulk stress. If the restoring forces are parallel to the surface, is called shearing stress. Strain. Strain is defined as the ratio of the change in dimension of the material to the original dimensions. It is a dimensional quantity. That is change in dimension divided by actual dimension. There are three different types: longitudinal strain, bulk strain, and shearing strain. The ratio of change in length to the original length is called longitudinal strain. Bulk strain, the ratio of the change in volume to the original volume. Shearing strain, the ratio of the change in lateral displacement between two layers to the perpendicular distance between the two layers. Moduli of elasticity, there are three different types: Young's modulus, bulk modulus, and rigidity modulus. Young's modulus, the ratio between the longitudinal stress and the longitudinal strain within the elastic limit of the material. It is denoted by capital Y, is equal to FL divided by AL. Bulk modulus, the ratio between the uniform force applied normal to the surface of the body and the area of the surface. It is denoted by capital B. Capital B is equal to minus PV divided by del V. The rigidity modulus, the ratio between the shearing stress and shearing strain is called shear modulus or rigidity modulus. It is denoted by capital S, is equal to shear stress divided by shear strain. Capital A is equal to FL divided by A del X. Determination of non-uniform bending by Young's modulus method. If the beam is loaded at its midpoint, the depression produced will not form an arc of the circle. The aim of the non-uniform bending method to determine the Young's modulus non-uniform bending. Objective: to deduct the maximum stress applied to the given beam by non-uniform bending method. This is bending mechanism in wooden scale by non-uniform bending. The materials are used in the non-uniform bending method: wooden beam, that is meter scale, weight hangers with slatted weights, pin and two knife edge stands, traveling microscope, Vernier caliper, and screw gauge. This is traveling microscope, knife edge stand and pin, wooden beam, that is meter scale, Vernier caliper, slatted weights, and screw gauge. This is experimental setup of non-uniform bending. The given wooden beam, that is meter scale, is supported symmetrically on two knife edges, such that there is 60 cm to 80 cm between them. A pin is fixed vertically at center of the beam. A traveling microscope is placed in front of this arrangement and adjusted so that the tip of the pin is seen clearly when viewed through eyepiece. At the point, the weight hanger is suspended at the midpoint exactly at pin. Then weights are ordered in steps of 50 gram and the microscope is adjusted so that the tip of the image of the pin coincides with horizontal crosswire. Then the readings are noted. Young's modulus of the material of the beam denoted by capital E is equal to mg L cube divided by 4p d cube s Newton per meter square. Capital E is the Young's modulus of the material of the beam. Capital M is the mass suspended at the center of the beam. S, depressions at the center of the beam. G, acceleration due to gravity. Capital L, distance between the two knife edges. And D is the breadth of the beam. And T is the thickness of the beam. The non-uniform bending procedure is followed until maximum load is reached. Now, weights are removed from both hangers in step of 50 gram and in case note the readings. Calculate the difference between mean readings for particular load and that of the dead load depression. Capital E for that load is calculated. To find the breadth of the beam using vernier caliper, the model values are shown in the table here. In main scale reading, vernier scale coincidence, and observe reading for MSR plus VAC into least count. To find the thickness of the beam using screw gauge, the screw gauge readings are, model values are shown in the table here. In pitch scale reading PSR, head scale reading HSR, and observe reading for PSR plus HSR into least count. Traveling microscope, loading and unloading values are noted and the mean values are calculated. This is the calculations part. Finally, I conclude that in the experiment, we have learned to determine the Young's modulus of the given wooden beam using non-uniform bending method. The Young's modulus by non-uniform bending approximate value of 1.278 into 10 power 10 Newton per meter square. Thank you.